Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Step 1. Identify the starting material, toluene, methylbenzene, which has a benzylic CH3 group. Step 2. Reaction with Br2 under light. Free radical benzylic bromination light initiates a free radical chain reaction. The weakest, most reactive CH bonds are the benzylic CH bonds of the CH3 group. Bromination occurs selectively at the benzylic position, converting CH3 into CH to Br. Product A is benzyl bromide, PHCH to Br. Step 3. Reaction of A with KCN, SN to nucleophilic substitution. Cyanide ion, CN, is an excellent nucleophile. It attacks the benzylic carbon of PHCH to Br in an SN2 reaction, displacing bromide and forming phenylacetonitrile, PHCH to CN, also called benzyl cyanide. This step extends the carbon chain by one carbon. Step 4. Hydrolysis with H3O+, heat, acid hydrolysis of nitrile. The nitrile group, CN, is hydrolyzed under acidic aqueous conditions with heat. The nitrile is first converted to an amide and then to a carboxylic acid. PHCH to CN plus H3O plus heat. PHCH to CO to H, phenylacetic acid. Product B is phenylacetic acid, a benzene ring bearing a CH to CO to H group. Step 5. Match two options. A. 2-methylbenzoic acid requires ring functionalization, not benzylic chain extension. Incorrect. B. Benzoic acid, PHCO to H, would require oxidation of the entire methyl directly to CO without chain extension. Incorrect. C. 4-methylbenzoic acid, ring carboxylation, not this pathway. Incorrect. D. Phenylacetic acid, PHCH to CO to H, exactly matches the product of benzylic bromination SN2 with KCN acid hydrolysis. Correct. Why other options fail? Options A, B, and C involve a carboxylic acid directly attached to the ring, CO to H, which would require either electrophilic aromatic substitution or oxidation of a methyl group directly attached to the ring. The KCNH3O+ sequence on a benzylic halide gives a 1-carbon extended carboxylic acid, ARCH to CO to H, not a direct ring carboxylic acid. Therefore, the correct answer is D. Therefore, the correct answer is option D.